technological solutions for this kind of byproduct for the dairy industry. So it's very, very diverse. Our teams, the program.
That's it. Actually, we are, like Professor Ivo said, we are working with the circular economy by refinery, and using the animal and vegetable sources. So we like to, we are able to produce the product and to reuse the waste in a circular process.
And as we are focused a little bit more in the starch and the byproducts from everything. So nowadays in the US, Canada, and also in all countries, people are searching for alternative protein sources. And so then the legume crops like the beans in Brazil, and the peas and others are very valid. So we have made some research with common beans, differently from Asia that use the beans for noodles like the mung bean. Here we use the Phaseolus vulgaris. This is the common bean for producing. In fact, it's in Brazil we eat a lot of common beans, rice with beans. Maybe you have notes already. Yeah, that's right. Yeah.
I like the bean of course. Morning or lunchtime.
So then, when we produce the protein from this kind of crop, we have a large amount of, let's say, waste, but it's a byproduct rich in starch. So then we are always trying to find out some applications for this kind of product. There are some dry process for separating protein from beans and from other legumes. So then you have a flour that is rich in starch. We have to do something with that. So then we modify the starch and we try to do some physical modifications or enzymatic modifications or green chemistry modifications, something like that.
Luana is our Master of Science student as well, and she's working with millet starch. Millet.
It's a cereal.
No, it's a cereal.
It's a
cereal actually.
It's a small crop from Africa.
She's extracting the starch and using the rest of the plant to achieve the nanocellulose fibers to reinforce the bioplastic using glycerol and other ingredients.
Just my comment, how about the energy for our life is normally we need 1,500 calories per day or more. If you are hard exercise, need 2,000 level. But in Japan, many people don't need so many calories. That's why they not only taking the glucose or amino acid or lipids, it's food for our energy. How about the Brazil people? Maybe it's already enough for consumption of energy.
Yeah, we have we have a lot of differences in Brazil. We have a great population that lives considerably good life. I mean, it's not rich people, but we have almost everything. But we do also have a very poor people, and then these very poor people we are living in this moment. The government says, and they have some data that we have some like to say food insecurity. I mean, there is lack of food. not lack of food, but the distribution of food that do not arrive to the very poor people. So we have some not so great problem, but in some regions we have some problem with this kind of worry that you are saying. But on the other part, we have also the problems of the developed countries. There is excessive consumption of food.
I should understand. Both sides are important. Yes, taking a very good consumption of energy from carbohydrate, protein, and other things. Of course, but not only that, we have better focusing more wasting part. For example, we don't eat because it's waste. It already exists in our society, but we must use it. Otherwise, our company cannot produce recycling or it stop if wasting is a lot in our society. That's why we have the better thinking.
Yeah, that's right.
So
we are trying to go this way because we understand that it's not only the economy, but it's the environment that also will be impacted with a very huge production of everything, and then we waste almost everything and eat only the very best part. So yeah, we have this worry also. And this is a global worry from the SDGs, from the UN. Yeah, that's right. So we are also, because of our financial need from the government, we are also always trying to completely fulfill the SDGs, and this is a very important point. Yeah, we're completely right. We waste a lot of. Professor Fleury that works with fish. Also, we have a lot of opportunities.
My name is Furuya. Furuya Masamitsu desu. My grandparents were from I forgot Yamaguchi-ken.
Oh,
Yamaguchi-ken. It's West Japan.
west of Honshu Island.
Yes, they ski as a little more diagnosed. Nice meeting. Yes. I work at the animal science, in particular in fish nutrition. I used to evaluate and develop some functional foods for the fish in Brazil. Brazil now is almost a great tilapia producer.
Yes. I taste it too.
600,000 tons. In Brazil. It's the fourth global producer. And this is the main state where the 60% of the tilapia is produced is the Paraná state. Most of the earth ponds, not the floating in the river or the other place, that's in caves. I have a partnership with a Japanese company. You must know Ajinomoto.
Now former my student become executive director of the Ajinomoto frozen food company now.
For the finger food or both. Ajinomoto has two parts, for animal and for human. And there's another one, health side,
Oh,
yeah, especially for sports. I've been working with Ajinomoto for almost 20 years, evaluating, developing some molecular special peptides for animal nutrition in Brazil, in Chile, in salmon, in Colombia, especially to promote growth and health of fish. The new era of functional foods, especially amino acids, is based on amino acids improving the health.
sleeping condition.
Yeah, especially good health and microbiome. This is very important that one amino acid does not only serve as to promote growth, but to enhance the health. We are now evaluating some non-essential amino acids, such as glutamine, not for humans only, for animals too, and glutamine, glutamic acid for fish, promoting to enhance the immune system. It's very important. Glutamine is very common in humans, no?
that's
Yeah.
Sodium glutamate.
Glutamine for humans now has been used for fish to promote the good health, to develop the enterocytes, to shift the microbiome of fish, and to particular to decrease the inflammatory process. It's very important. And glutamine, yeah,
Inflammatory.
yeah.
You mentioned. Inflammatory.
Especially glutamine, because they both are changed. No? Glutamine from glutamic acid, not glutamate, and glutamic acid changed to glutamine, and both. There's a conversion. This is a new
But
development in animal science related to amino acids.
you know what is working on that? Producing this glutamine?
Yes. Do you want to produce all of the amino acids, essential and non-essential, excepting methionine, because methionine is a seed used to work the BAS from the German, especially with the vitamins and enzymes, exogenous enzymes. Not developing, of course, not here. I used to validate the application of exogenous enzymes and vitamin for tilapia. Developed it for all kinds of animals, and we are the unity in America that validate the use of enzymes and vitamins for tilapia globally here in that state. Interesting, because especially fibers and carbohydrates are very useful for Brazilian aquafeeds, especially tilapia, because there are a lot of plant food ingredients that contains a lot of fiber and non-starch phosphorides that start a little the absorption of the digestion and absorption of nutrients. And the exogenous enzymes inclusion helps to increase the digestibility by also promoting the microbiota, beneficial microbiota. Because once the non-starch polysaccharides are released, can release molecules that are serves as a food for the bacteria and for beneficial bacteria, increasing the production of short-chain fatty acids. It's very important. Yeah.
So then, as you told, when we are looking for, in fact, me and Gustavo, when we are looking for our research themes, also one of the biggest worries is about the kind of non-transmissible diseases like diabetes. So then, as we work with carbohydrates, and also in Japan, you have a very developed carbohydrate chemistry. So that's also a very huge worry here in Brazil. I was living for 1 year in the US, and there we have a very good contact with a very famous Japanese scientist from the starch chemistry, kind of. His name is Dr. Kainuma. I don't know if you have listened to it, but I think he was based in the US. And but then we were very focused on the starch digestibility, so this kind of resistant starch and all this kind of slowly digestible starch. And we have very good discussions over there. And the worry was in the US they think, and they asked me a lot about Brazilians, if we have a lot of diabetes or not. Because diabetes, in fact, the type 2 diabetes is kind of a rich people disease in the past. But nowadays, we have a lot of consumption of, like in Japan, of polished rice, and also of bread. In Brazil, we have a lot of consumption of bread. And also, of course, in this case, like in the US, very huge consumption of soft drinks. Yeah, that's a big problem. So then it is not possible today to separate people that has more incidence of diabetes, type 2 diabetes, from the place they live. Because here also all the globalization spread all this thing. So, and also another worry was with hypertension, as you mentioned. Yeah. So then we have developed, but this was a cooperation with a colleague from another university, some kind of research with active biopeptides, like you taught us. Yes, these biopeptides are very powerful in blocking some kind of reaction. It's very complex chemistry, the biochemistry of the interaction with the organism, but it's very promising.
Even in my particular opinion, the main difference between Brazilian and Japanese habits is that Brazilian food is very salty compared to Japan. Very salty. Very salty.
Beef, yeah. I don't understand.
A lot of sugar,
Yes.
a lot of fat, and the main difference is the quantity. The Brazilian people used to eat a lot because the Japanese they used to have salt, some foods are salt, some foods are sweet, but the quantity is very important. The quantity. Brazilian people used to eat a lot, full in protein, animal protein, vegetable protein, but very salt. No. Salt in general compared to Japan. Salt is because not about only the quantity of fat, because Japanese food in general has some fat, it's fried, but not so salty. But the quantity that Brazilian people used to eat is a lot compared to Japan,
Almost in the other countries, it's sweet.
It's sweet.
If you develop one protein, if it's not sweet. Brazilian people don't like. They like sweet.
Have you tried the Brazilian soda?
That you have.
Brazilian soda, Coca-Cola in Brazil is sweet and very darkness. No, compared to, I'm not sure about United States. In Japan, I was in Japan 7 years ago in Tokyo, and I tried this soda Coca-Cola. It's very soft compared to Brazilian.
Really? Oh, I didn't understand the little bit different taste of Coca-Cola.
Yeah, the orange juice here is sweet strong,
But Professor Tamura worked with the hydrolyzed carbohydrate to come sweet and not you can't absorb.
Do you use to evaluate the
Sabor doce.
carbohydrate hydrolyzation? No.
Our university has long history of study digestion of carbohydrate to the monosaccharide. It's to think one way is production or the composition of the sugarcane and sucrose.
That's sucrose.
If we can digest it to the monosaccharide, sweetness will increase, right?
Definitely.
Right?
Yes.
Like that. We are using always enzyme. They improve the character or some taste, right? Then
To
we
improve the taste or the utilization? Both.
sweetness increase.
Wow.
Sometimes. Then one professor moved to actually Tsukuba University after finishing his work about this kind of work. Then another professor tried to convert fructose, a kind of sugar monosaccharide, to the new type of allulose. It's very rare in nature. But the sweetness is 70% of sucrose, glucose. Also calorie zero.
Wow.
And then we asked to the Coca-Cola company if you can use our product. Both sides is happy enough. Then establish a new company in Mexico right now. We want to produce a lot of just one kind of monosaccharide.
From sugar cane or no? In Mexico?
Possible. From sugarcane to the fructose and then convert to the allulose. Yes, we have a pilot plant in our university for production of allulose.
It's a five or six carbon.
Yes, 6 carbon means hexose.
Hexose.
There are 8 kind of hexose in this series.
Yeah, that's right.
One
And
kind
you are
is
producing an allulose.
Oh, it's ketohexose, not aldohexose.
Okay. Like fructose.
Oh, yes, I see. Fructose itself is 40% of digestion if compared with glucose.
And it's a little bit sweeter.
Sweeter, but calories lower.
Yeah, that's
That's
right.
why if you eat fruits are rich of fructose.
Wow.
That's why you can't get more body weight. But in case of our fructose, allulose, almost 0 calorie means.
And this is an enzymatic conversion.
Yes, enzymatic conversion. I take it here, I will bring it here, but I forget in the bus. After, if I reach to the bus, I will provide.
Just like so Japanese are very they are completely leading in special sugar. So yeah, that's great. You have. I was talking to Professor. I have listed a plant in Japan of trehalose. Trehalose is a very special sugar also. So no reducing glucose. There is anti-freezing properties and something like that, and have a very important market.
Normally, sticky rice is easily solidified, very hard, change to hard from soft. But if we use trehalose, extend the softness for long period, That's
Oh,
why many food company want to use trehalose.
And in the past, this trehalose was extracted from the yeast. So in the alcoholic yeast, you have trehalose. But in Japan, they have developed enzymatic pathway that is really cheaper. They dominate this technique.
Yes.
I think Takeda Chemicals
Oh.
or Hayashibara. Hayashibara. That's great. So Dr. Tamura, about your, so you were a very experienced scientist, and your background is from biochemistry.
My background is organic chemistry.
Chemistry.
I can study a lot of finding the new chemical in nature or food. But if we see about barley production, it's a kind of grain, then Japanese well known. Some of the barley has very good activity of our health conditions. That's why we classify 3 levels of certification of importance of functional food.
Wow.
Most important one is medicine level.
Mhm.
Companies should study everything of safety and functionality of final food products.
Wow.
But it's very hard in small company. Another type is just offer the mineral and vitamin level of their own products.
Mhm.
In case of vitamin C, if reach more than 100 milligram per 100 gram,
Wow.
we can display, this is important for
High
our
quality.
health.
Yeah.
This is a very easy display on the packaging.
Wow.
But final one is the company itself can ask the display of importance in the packaging. That moment, companies should collect the data. They don't need research work. Just collect the data from all of the country's papers, and then find it. Then show, this product is very good for keeping the health. Or then we are making the society in Kagawa Prefecture. One side, government want to promote gifting some budget to the company that they can ask the certification to the government. It's a consumer affairs section of government. Then one side is of prefecture researcher institute should check the contents, how much contain in the food. My case is a likely small president of such a society, then promote more discussion, exchanging information. It's a kind of the
You mean for labeling and for such
labeling,
kind of commercial and the health
claim,
insurance of the food?
yes,
That's great.
It's a local
I
group,
see.
but still promote
That's
the
So that-
benefit of the company.
Yeah, that's a very up to date worry of the consumer to have very
yes,
safe food, and also I don't know if you have heard of I think yes, we have a Brazilian scientist that have created a kind of a concept like ultra processed food. So then this is a very big challenge for the food industry. This guy is from the nutrition field. It's a Brazilian scientist from the University of São Paulo. It's a very famous one.
Yes.
And globally, he has printed this kind of concept, ultra-processed food. For the common people, it's becoming very worrying because everything that passes through the industry seems to be a venom, seems to be bad for health. So it's a simple kind of vision that is creating a lot of fight in the food side, I mean, so this is very important for us because the food industry is beneficial for the society, of course. But we do have to be very responsible also because, as Professor Ferreira said, in Brazil, people it's very large amount of food, yeah, and the industry, as we produce a lot of sugar, a lot of grains, a lot of protein, so food is relatively cheap. And the industry, of course, wants to make money, and then they produce very cheap food and sometimes not so safe food, like a lot of sodium, a lot of sugars. There is very dangerous for glycemic index and something like that, and also a lot of fat, a lot of in excess of protein also. So this kind of work is very important because I mean, educational nutrition education is very important for people. And here in Brazil, especially because people do not read the labels, do not understand what's written in the label. And for example, we have one people that work in my home. Sometimes very few times she goes there to make some arrangements in their house, and she has diabetes type 1.
Type 1.
Yeah, very dangerous. And then when she leaves our home, sometimes she said, "Next week I will not come because I have an accident." Wow, an accident. Yes, I fall down and hit my head. And then we start to take a look in the fridge, and we find out that we buy some orange juice, pasteurized orange juice, very fresh one, like the freshly made. They are prepared, very very good. And she was drinking that like crazy people because she doesn't know that the sugar that is over there is the same sugar of sugar cane. So as it was not written that is sugar added, she didn't realize. Can you imagine that? She didn't realize that this could be not allowed for diabetic people. So then I explained her, but it was kind of a coincidence because I asked her, "Do you have some kind of different thing that you eat or drink here?" And then she said, "I love the orange juice." And then the orange juice, it's a 2-liter bottle. Every time she goes there, it's only like a finish of the bottle. And so, that's in Brazil is very challenging to communicate people what they can, they cannot eat. And even though the things that are good to health and not so good, so people like eat snacks and things like that doesn't bring any benefit to health in large amounts, like in the US. And so this is a kind of.
In my lab itself, I have some animal cells then using for testing or protection of disease. I'm not a medical doctor, means I cannot cure the patients, but I can offer some information. If you eat this a long period, you can't be patient in future. Means I studied anti-diabetes by cell culturing because cell is normal, but putting the hormone and then change its differentiation to the more fat cell. Then we stop making some differentiation. Then we see, this food product prohibit the pass to the fat body weight sometimes, or anti-allergy, anti-cancer. It's my target of lifestyle disease. Then I'm chemist, that's why I'd like to find out what chemical is important in food. It's a final my objectives. It's okay. Anyway, for example, our local city is very famous for olive oil production. If we want to continue it for a long period, because number one, 95% of production of olive oil in Japan is come from our city. But we are always thinking how we can use waste, pommes and water parks for example, then we think about pomace is still contain oil. It's a rich of unsaturated fatty acid. It's good for health more than saturated fatty acid. Right?
Yeah.
Like that. Then we take the feed to the it contains many unsaturated fatty acids.
Yes, yes.
If we put them, maybe content or
Will not change.
composition is worse,
Yeah,
right?
yeah.
That's why we collect the leaf. We must cut the leaf in spring season if we want to grow very well the olive tree. Then we make a powder, then give it to the fish.
Wow.
Then texture of fish change a lot.
Yeah.
Then people love the such sashimi taste of the
It's better.
fish much better.
Because you change the fatty
become-
profile, no?
Becomes a little bit harder.
Hard. Yeah,
That's
correct.
That's great.
But this kind of thing, we must do it. Tsukuba University is a top university. They don't care about local society. But our small university should take care of the local industry. That's why we are thinking this kind of collaboration, making good condition in industry, our university itself.
Oh.
Just a small story.
Thank you very much, Dr. Buda. I think it was very clarifying and very interesting to have the opportunity to listen to a very experienced people that worked a lot with many things. And at the end, when you reach a kind of very good knowledge, you try to solve problems. So at the beginning, you start to understand the very specific chemical reactions, but now you are dealing with very complex final scenario of the food
I'm
market.
happy.
Yeah.
Share.
Very nice. Thank you very much. And Dr. Rivera. Yes. Okay.
I'm from the Philippines. I'm assistant professor at University of the Philippines, Banners, which is known for agriculture and forestry. And I'm studying PhD in bioindustrial sciences under Watanabe Sensei. And my work is actually not on food science, but in applied botany and molecular biology. And my work now is on wild species of ginger. And I'm doing tissue culture and metabolomics, especially volatile oils. So I'm actually doing natural products research. And I'm also doing bioassays using animal cell cultures.
Wow.
Yeah. So you mentioned earlier about diabetes, which actually connected with inflammation.
Yeah.
So I'm actually doing anti-inflammatory assay using mouse model cells.
But you work with cells or with the mice?
With cells.
Cells, yeah.
So
It's very difficult to work with
in vitro,
animals.
in vitro.
Yeah.
In vitro. Yeah.
So we're looking into mechanisms and how volatile oils from the ginger can affect cells in inflammation, as well as we also do for neuroprotection. So we're using neural cells. And I also have a task by Watanabe Sensei to promote the University of Tsukuba. So if your students are interested to study in our university, so maybe you can contact me or Watanabe.
Wow.
That's a big
Great opportunity.
Because
It's a great opportunity for
So aside from academics, I'm actually enjoying the culture. That's what Cedric said. It's really different between the culture between Brazil and Japan. Even Philippines is still different. Our culture is still different from Japan. A very good experience for you to study.
Yeah.
You might be interested to study.
It's great. Yeah, it's great experience.
Brazilian people enjoys ginger. But we usually eat sashimi with ginger, and not with using wasabi.
Wasabi.
In Brazil.
Oh,
It's different.
Find it.
Because, Japanese people use only wasabi for sashimi, but Brazil, most of people use ginger.
Every year invite South American young people to our university under the JICA project.
Yeah.
That one, my duty is explain the wasabi taste. They finally make a sushi with them.
Yeah.
Last year,
Because wasabi is very expensive in Brazil. It's very expensive. Lots for ginger.
mild.
Yeah.
Professor Rivera, are you studying any kind of beverage by using the ginger?
Oh.
No.
Because I'm really not into food science, food innovation, so the upstream or downstream.
Okay.
So more on evaluation.
And this is another example of a starchy result that we explore here. Also, you have also, of course, the ginger is produced for its medicinal and also the aromatic properties. But then when you extract the oil, you have a lot of very starchy waste, let's say. So we have already made some studies on stuff like the ginger starch. Yeah.
I was asking you because some, I guess, was 7 years ago, we, Professor Rigo was a part of that. We produced a beer from the
Ginger.
no, but from the black rice.
Black rice.
Black rice.
Black rice.
We-
Wow.
Brown rice.
Because of the
It's
compounds.
It's wild rice with black color, yeah, black color.
Black rice.
Because of the other compounds. And then we could avoid the pasteurization process. Because yes,
Because of the phenolics, the product has a very
the beverage.
good conservation. It's very
It's probably that the Brazilian ginger is different from the Japan, no? Because of the soil, the climate. Alright.
Is it native from the Asia?
Actually, the one I'm working is in Southeast Asia, India.
Close to you, Philippines.
Close.
Very interesting. So in Brazil, what we have is a huge amount of opportunities with new raw materials. In this region here in South Brazil, it's not so much, but when you move to the other biomas, like Cerrado and Amazonia, you have a lot of things that are different. And sometimes we find something that's related with something from Asia, so it's very, very sad.
My colleague, 3 years before I retired in university, and then now appointed a specialist of one program in Kagar. I'm still working in Kagar University, but my colleague become now professor of my research area. She's a Brazilian, study Kagar University, and after that moved to the government institute in Tsukuba, 5 years, I think.
Wow.
After that, she got a job in São Paulo University, but quit job by 2 years. And then moved to the Nottingham University, England, UK. Then finally, I invite him
Back to Japan. Back to Japan.
To Japan.
to study the guarana, importance of guarana extract. then maybe she collects sample from Brazil. I think.
Nice, yeah.
If you can collaborate with her, I'm very also happy.
Wow, very nice,
Oh.
right? Very nice.
She's a lot of interest in the bioavailability.
You have caffeine, other chemicals as well. It's very interesting. Okay, that's very great. We are very. I don't know if JICA has improved it or increased some kind of. JICA are very important because for Brazilians the life cost in Japan is very expensive. Like in Switzerland, it's very expensive. So it would be very nice if we would manage some kind of opportunity with JICA. Sure.
JICA is still active and they have increased.
But yeah.
We also have in our laboratory we have a scholarship.
Uh-huh. So I was telling them I was making a training course in Japan, very famous one. Professor Glaucia Pastori was a classmate, not from the same time, but it's a famous Brazilian researcher from University of Campinas. She made also this training course in enzyme technology.
Yeah.
So we start with coach fungi. I think that it was. Kind of a risopus or something like that. And then we extracted the lactase. In that case, what was a beta-galactosidase from the very beginning until we reached the only one protein plant in the electrophoresis. So it was a complete training course of 5 months, very important. And then we go to many factories and to many visiting places, and also it's a very good experience. Then we hope that our students can have this kind of opportunity. And that's the importance of being here, thank you for you and for the students here. Because professors here are coming to Brazil to find opportunities together with us. So it would be very nice. For my life, it was my first experience of relatively long time experience in Japan. But then after that, I went to other countries because this opened me also many opportunities because the scientific community is small. I was asking Professor Tabura if he knows a friend, an emeritus professor also from the starch chemistry field. But of course, the areas are very specific. So we know a lot of people, but the field we work. It's very important for you that are young people to make these contacts abroad because the experience they have there, like you are facing from Philippines in Japan, we learn a lot in Japan. And, the thing that I thought it was more changing from my mindset was that the dedication and the focus is very deep. And the respect also for the work of the others. There is a competition, but it's a good competition for making the best you can to develop science. So
this partnership is very important because we have a variety of material, high quantity of material, but in general terms, we don't have the support and governmental support to in Brazil it's common because we don't have support, financial support. We have, but not the same, not equal. We have support, but not the same in America. I don't know, not sure about Japan.
But
compared to America.
But when I was there, we visited University of Tokyo, for example. It was very nice.
Yeah.
But then when we arrived over there, it's a very good experience. When we arrived, the building was very old, and that was It was missing some kind of painting or something. but then the people that received us, it was people from the residence. She said us, please, sorry for the appearance, but please come here and take a look at these people. There was 5 pictures from the 5 laureates from Nobel Prize. So then she
wow,
said,
yes.
this is our biggest honor is to have these people here. And this is the very important thing. That doesn't mean exactly what you have to see, but what you produce in the science. So it was great. But on the other side, when we went to very huge companies like Kida Chemicals, they also, people from the laboratory I was working, they say in Japan, the big money is in the companies. So yeah, the private companies, they developed a lot of research and development. This is different from Brazil. Unfortunately, our companies do not put money in the research and development. They only try to find out some free consultancy in the universities, and we have something to develop, still to develop. But like in the US, in Japan, also the companies are very huge and do a lot of research.
Yes.
Yeah, and that I think the PhD that you produce in Japan, most part go to the private sector. Yeah. Like in the US. In Brazil, when we finish the PhD, we have to search for an opportunity in the public area, so it's not so easy. And also the investment of the government in the research field sometimes is floating. So sometimes you have money, but the other year you don't have. So then it's difficult to plan in long term.
In our university, Paraná-Japan has a strong connection with a private company now. So with regards to, for example, we need materials, we can easily get it. And another thing, we need to publish paper, international publishers. So the company also give us money to. So it's only up to us students to produce papers.
I think this is a global tendency. Unfortunately, the problem is that in Brazil, our Brazilian companies, in fact, few of them are developed to a place that they can understand that research is fundamental for improving the money. But when you have the huge companies that make research, then you have the support. When I was in the US, it was a postdoc position. My advisor over there, I asked her, Professor, I will have the scholarship from Brazilian government, but that's only that I will have. So I will have insurance, I will have all the things I need for myself, but I need your lab, your money, all the things you have in the lab for developing the research. And then she told me, please, you can come because I have a lot of companies, Quer, and ADM, and all the American companies that work together with us, and we have money from the companies, not from the government. So it's almost the same, yeah. But here we are some steps earlier from that. Maybe one day companies will give money. But Furuya, for example, he works very hard with international companies like Ajinomoto and Basque in America.
It's an opportunity for us to share in this partnership.
Yeah. And also
a lot of opportunity to work together.
one thing important that you should know, the city here, the very big Japanese company is establishing a big factory from Nissin Ramen. And also we have Makita, that's a tool company that produces tools. Yeah, not from the food. Here in Protagraça, Makita. There is also Harima. Harima produces ships. No, this Harima produces essential oils.
Oh, really?
Essential oils, yeah.
Oh.
It's a big company here, very, very nice one.
In Protagraça?
Yeah, I have visited. Yeah. And the other one from Japan, There are a lot of. Sumitomas from the tires, yeah.
Yeah.
There's what else here?
Alguém quiser apresentar o apresentação.
Nas outras instituições, foi a apresentação do trabalho que alguns apresentaram o trabalho que já fez, né? Mas depois a gente maior mostrar o que a gente faz e o que podemos fazer, né? Para poder fazer uma interação. Aí teve algumas, cada um fez de um jeito, né? Não teve apresentação. Se vocês quiserem, pode também apresentar. Porque ele está pronto para o material. Ele tem. Se perguntar para ele,
You're going to present a presentation. If you want, you can use the computer for presentation. If you want, I'm not sure. Do you have prepared a presentation? Or?
My computer was broken
I
now.
don't have here.
But I have only.
No, you don't need, only if you want to introduce your work.
How long will we still have time?
You can stay here for more 1 hour.
1 hour more.
Yeah.
são 10 e 15, deixar 1 hora ou não.
No, but 1 hour for everything. So
Oh,
I don't know if
maybe
you want to.
15 minutes. Okay? Or 20? Or how long do you want the presentation?
I don't know.
You are free to present
Yeah.
here.
I can say for you, okay, 5 minutes if you finish it like this.
Don't worry about the time.
Não, porque nós temos horário, né? Só que eu vou sair. 11 horas, não.
É 11, 15, 20, 15
Fica dentro para eu montar. Aqui é tudo pior do que esse. Pior do que você fala. Não, é porque nós temos horário para sair hoje.
How about the second one? Yes.
Então, por isso eu posso falar para ele, né? Mais ou half hour is okay for you? Half hour is okay for you? It's a lot of hours, but it's okay.
Yes, you can present in less time, but then at the top, half hour. Okay? No, yes, you can finish it early. The time that one just cannot pass half hour, but you can finish it early. If you want to go to different time. If you want to have a water, to go to the bathroom.
You managed to have a coffee, but sorry.
Olha, 86.
Ah,
2003 só.
Eu tenho 30 anos, eu tenho.
Obrigado.
Mais 7 anos eu já aposento pra ele.
Pois é.
Eu não pisei no cabelo.
Meu filho
Vou chegar.
Vai cá. A tua filha.
Nós somos alimentos funcionais, não, mas é a raça. É a raça.
Engenharia mesmo.
Alguém aceita água, suco?
Não gosto nada.
Alguma coisa assim, se eu fizesse aqui a parte de lá, teve alguma coisa assim.
Aí se eu pegar o número, está escrito lá.
Aí
A gente pode fazer tudo aqui.
foi alguma coisa assim. Então teria que ser uma função daqui para trabalhar lá, daí essa parte deu muito certo. Aí mais eu converso
Então vai ser.
porque eles são vai para inicial.
Essa minha não, a minha foi direto para o Whey.
Entendi, porque a UEM faz parte, porque a UEM não poderá, a gente, na verdade, é um prazo, seria alguma coisa que não foi fazer, foi uma burocracia, alguma coisa.
Oportunidade.
Dando aula, deixei de aula.
Mandar o e-mail.
I want to skip something. Maybe as I mentioned before, our government has some regulation law of food importance. The most high regulated display or on the packaging is food for specific health use. All of the products should be test human activity or human physiological activity for human. This is quite similar with medicine itself on high level. The second, of course, vitamin or calcium, like a mineral, is important. Everyone knows it. That's why if you understand the amount of mineral or vitamins, you can display this food with nutrient function claim. This is easy to display on the packaging. But I mentioned final one is established 2015 by government. This was just get the scientific review, look for the papers, and then get to the importance of food components. Normally, if we don't find any chemical in food, we cannot say this kind of thing.
Okay.
Only exemption of that is yogurt, probiotics. In this case, without any chemical evidence, still government accept. But this is just one exemption. But other case need what chemical is influence to the improvement of our health claim. That's why if you understand this level, maybe you can easily choose what we need for future protection of future disease or some patient. General food is here. Also, we have another dangerous things, this or quasi-pharmaceutical product. This is not real pharmaceutical product. But there are many regulations or rules in food consumption.
I have a question. In which class would you put the supplements? I mean, this, I don't know how is it in Japan, but for people from the sports and things like that, supplemental foods like creatine.
Supplement case might contain calcium or vitamins. In that case, this thing. Actually, calcium 220, we can say something nutrient functional claim like this. In Japanese, this is.
Nice, yeah.
Then this is a medicine level. Some of beverage good for health
Oh.
because Coca-Cola with 0 calorie, for example,
Low calorie.
not delicious, but
Yeah.
good for health.
But
Then,
it's for diabetes.
recently, we recommend for small company food with functional claim. Started to 2015. This is a yes, body weight might be decreased. We can display like this by casein, maybe lactobacillus in yogurt.
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 I mean, we had a problem with the
Problem?
transmission. You just
Mhm.
help us. Because it's usually transmitted in the YouTube, but the image frozen.
Ah,
So you try to just
provided in some lecture in Vietnam or other places, but not yet established
I see.
in government. Maybe in future they will.
Yeah, very complex.
you can
Can?
yes.
Cannot? Huh?
Okay.
How to?
Just a minute. Where's the
I can see my face, but wow. I can see my face. I don't need.
this?
Oh, but still frozen?
Okay, no, it's okay.
Oh,
Yeah, here.
yes.
That's you are.
Okay. Okay. じゃあこれから。Sometimes, if the company found some mistakes, they can withdraw the displaying. One of the company cosmetic company Kao was withdraw their data or display on the packaging. Econa oil was disappear in the market. Like this, if they believe it is not good for consumer, they must withdraw. Such evidence is wrong, but they don't tell us reality. But anyway, they read this one. But many companies still keeping the on the packaging some display. This is the iron containing beverage or yes, like that. Why we must establish this kind of things? Because if people, consumer want to understand, oh, this is good for lifestyle disease, maybe they want to prevent the hypertension, the moment, or sometimes we need antioxidants. If we see the background of the science, some days, almost all the days, initially some England researcher published some epidemiological study of red wine. It's good for our heart disease. Then this is the data of Japan. After the publication, normally we, especially lady, don't like red wine because it's bitter too much. But white wine is sometimes sweet. The lady normally choose white wine. But after the 1994, yeah, increased a lot of consumption of red wine like this. That's why company want to promote more selling market, because if they display something, yes, consumer choose it more than normal food. Right now, yeah, this is just information of Japanese red wine. Maybe next time Brazil red wine will increase this display. And if we see the what type of the importance for against the disease, if we know very well about this, what type of display is important on the packaging? If we can decrease the high blood pressure, of course it's good for health. Then we are sometimes focusing more LDL. It's understand that.
Good cholesterol.
Yes, bad cholesterol
Bad cholesterol.
value should be 140.
This is okay.
Our olive oil also has this kind of effect. That's why we display the importance of this kind of things. Also, if we decrease the neutral fat, it's related to this kind of things, heart disease, brain disease, and hypertension, I think. If BMI, in case of Brazil, BMI requirement should be 30, I think. But Japan case 25. I don't know difference, but in the world this is quite common. But Japanese, I'm almost reaching this value.
Maybe the amount of food you eat, and also the lifestyle is better than ours.
It's related to the diabetes. Also, we also evaluate this kind of things. Yes, the other things, the allergy or sleeping period or other things is a target of such claim of food, functional claim, right? Then maybe, in my case, one of example, this one. I collect stinky bean. bean is on the tree and collect it. Normally we cannot import, but one company in north of Japan could get it. Then I collect it.
Wow.
Then I analyzed anti-cancer activity, but I don't use cancer cell. I use normal cell. But see, putting this extract, we prohibit the cancer cell promotion, increase cancer cell. The final result is this kind of thing. It's a volatile compound. I'm actually flavor chemist also. That's why easily to correct this kind of smell chemical easily. Then activity of this was very high. Finally, I can understand the importance of smell. Oh, freezing. All right. Next. How to measure? Normally, cancer cell formation was going this way. Just one of the cell was damaged by UV light or irradiation or some pollution or other things. Then that chronically increase of such cancer cell, likely malignant cell will increase. That before coming this situation, there is one of the important step here. Normal cell, right? But already irradiated means going to this way. But this is a reversible. In this case, reversible. If we, when I put, sorry, what? And normal cell, but cell contains some damage of DNA sequence. Then put the promoter, this is promoter, going to cancer cell. But by putting the extract here, we can protect the going to the cancer cell. That's why I don't study the just toxicity of cancer cell. We are using the normal cell. But check this kind of, I try many type of samples. Then finally, this is a more important chemical from yacon leaf. It is grown in Andes, in Peru. Then some researcher in Shikoku, my country, collected the cultivar of yacon leaf. That's why I study more and compete with São Paulo University, but we found a new chemical and a new activity of anti-cancer. Also, some of the green color or at this moment, yes, we found that some sulfur compound is good for anti-cancer activity. Our Japanese love the mushroom very much. Mushroom, we are thinking it's a healthy food, but nobody tell what chemical is important in mushroom. But stinky bean has same chemical in mushroom. That's why we understand, stinky and the mushroom has same chemical means, mushroom is good for health for us. For example, wakame or some seaweed also, we are believing it's a healthy food. But chlorophyll itself is not good for anti-cancer. But after treatment or like a processing of food, change to more important chemical in this case. But like this, I can study more about this one. Okay, yeah, これは from yacon leaf, and this is a shoga. Still okay. Some researcher in from a university study curcumin also important, but this is a higher position. Also stinky bean component, sulfur component, more than this. Very good activity. OK、ちょっと待ってくださいね。で、go to end, maybe. This is a, まあ、anti-allergy. When I study, OK、ちょっと待って。どうしようかな。In case of, 違う。Anti-allergy, we are using this kind of RBL2H3 cell, rat cell, animal cell. Then see the releasing of hexosaminidase and 何でしたっけ? It's a histamine releasing. We protect this releasing rate, like histamine release. Like that. Then I tested many kinds of onion produced in Kagawa Prefecture. We have a very big company who produce a variety of onion. If I collect data of these things by biological activity, I understand if the releasing rate is very, very low, it's the highest activity means higher. Then some cases very low, right? This is easy to get such data. If you start or students start to experiment, easy to get. But finding chemical is not so easy. In this case, I recommend my students, please analyze chemical by HPLC or other analytical way. Then see the peak in the chromatogram. That's it. Compare the activity with amount of chemical. It's a statistical analysis. Means we can choose which chemical is important from the HPLC data. Then finally, I can easily understand some of flavonoid is good for anti-allergy because I originally focusing one chemical. This peak is very related to the activity. Means maybe this peak is important for activity, like that. That's why my approach is quite quick, easy, and get the final result easier. Then after publication, my colleague in Chiang Mai University, Thailand, look my data and then request me, oh, please analyze our shallot very close to the onion. Then I test it. Then I compare the activity. I'm very glad. Their product is more active rather than our product. That's why they are very happy because they have many good samples in their country. Then my counterpart was a medical doctor. That's why they test the activity by human. That's why this is a nice result for further functional claim. Very important data for me. Like this, I approach many. Olive oil also contain some of the herb contain. Also, sweet potato has some good chemical.
Sorry, you mean the orange flesh sweet potatoes?
Sweet potato.
But orange sweet potato are the starchy one. Do you remember?
I test several types in Thailand and Japan, but only one variety has good activity. That moment, yes, it's a Naruto Kintoki is grow my neighbor prefecture. That's why they are also happy.
5 minutes.
Oh, 5 minutes. That's why I go to
You have a lot of time. 5 minutes.
5 minutes. Oh, this maybe should not talk about rare sugar. Their sugar.
More than 10 minutes.
10 minutes left? No?
He gave you more 5 minutes. 10 minutes.
Always, as I mentioned before, maybe for activate food factory by supporting the functionality, yes, getting the evidence of, yes, labeling approved food, analyze of amount is important. Kagawa Prefecture has one research center. They help the analysis. Also, one of the foundation, Kagawa Prefecture Foundation, name is what? Kagawa Industry Support Foundation, will guide the help proposal to the functional claim. They offered some budget also by this foundation. Analysis and support the proposal. We have research institute in Kagawa Prefecture. We are collaborate together. We always announce what company propose the new functionality to food products. This is a research group, or Japanese, it's okay. Some case, yes, special wheat じゃなくて barley has contain beta glucan rich. This is nice for prostaglandin blood glucose level. This was already proved in US data. That's why we can just easily ask the claiming of functionality with 65 grams of sample of this.
Is it barley or oat?
Barley.
Yeah. Okay.
Probably.
Okay.
Very sticky.
I see.
We are helping that one. Maybe next time I want to talk mycotoxin because we have a long collaboration history with Londrina University and the Kagawa University. Then we are
Professor Hiroka.
Hiroka.
I have a partnership with her.
Oh, really?
Yeah, she's
Long time we after establishing new analytical method of mycotoxin, always gifted to the her group.
Elisa Hiroka.
Yes. We want to still continue this kind of thing because food safety is the most important thing after we getting new products. Without any checking the safety, we cannot export it or cannot produce, introduce to the market. Very difficult. Then his group was try to analyze many type of mycotoxin. And this is a methodology of still not a methodology. This is methodology. Some of the cancer cell was immunologically activated cell was fused together and then select by this kind of things. Then enhance activity very much. Then we can easily correct the antibody from this series of work. Already this was established, but nobody do it. Nobody get the very high reactive antibody, cannot get so much. Our colleague can do it very well. I'm not sure why, but this is actually now many of mycotoxin can be analyzed in my area of Kagawa University. Also, I was the director of food safety program in master program in Kagawa University. I started in 2009. That's why I'm asking the your student to our program from since 2010. Then at that moment, I met the Hiroka, Elisa Hiroka. They introduced them. Our counterpart is Ajinomoto company, Nichire Table company. Then they support financially.
Wow.
Then we are running it, still running. That's why I can introduce this kind of thing if your student want to study. But this is a program for student can learn Japanese, can learn more research work, they get a job in Japanese company. And then some of the students, yes, still working in Japan. Also, we have English program, but it is quite normal. I don't need to explain more detail. This is the inside of the program. Another thing is, maybe I must mention this one. Kagawa Prefecture is government, local government continuously send students to Sao Paulo. Maybe stay certain period. This is still continuing.
Very nice.
I'm
Kind of immersion.
That's why our prefecture is very good understanding, collaboration, exchanging program is very important with Brazil society, I think. Then of course, this was why, because Imayuki Shinichi is a former professor of Kaga University, sent many his students to Brazil, like him. Then our prefecture understand Brazil is a good counterpart or good partner. That's why still we are continuing this kind of thing. Oh, maybe finish.
Yes, you have. Like 10, 15 minutes.
Mais 10? Vai
For next
Okay.
So as I have said earlier, I'm working on a wild species of ginger, which is the Campharia galanga. I also worked with this plant during my master's thesis in the Philippines. So I used the accession from the Philippines. And this time, it's actually somehow a destiny. When I met Watanabe Sensei, he actually told me that he has more accessions of this plant, actually from Myanmar. So it has ethnomedicinal properties, and it is considered to be underutilized. So most people don't know this plant. But at the same time, since it is wild, it is considered actually as an endangered species. So we have many problems with this plant. So I conceptualized this research for my PhD studies. And first is I wanted to check or to describe the accessions that can be found in Myanmar. So I use botanical studies like Morbo anatomy, and then looking at its diploidy level. So we can characterize what if they are the same species, different species, or they are on different varieties. And I already finished this part, and I noted that there are actually 3 varieties of this plant. And then there's a research in China that they noted that there are only 2 varieties. So this time there's already 3. Yeah. So looking at this part, I also wanted to do metabolomics, chemotypic variation, since there are already 3 accessions or 3 varieties. So I did GCE, GCMS, gas chromatography, looking at into its volatile compounds. And surprisingly, those varieties, they are also have different volatile components. So probably I noted that they can have also different bioactivities. And to do that, I evaluated them using cell cultures, looking at into its cytotoxic as well as anti-inflammatory activities. So I'm using raw macrophage cells, at the same time using RT-PCR. So to evaluate its cytotoxic and anti-inflammatory effects. And gladly, those varieties, they also have different bioactivities as relative to their volatile composition. But I will not give details on the results because actually we are already on the writing the patent for these 3 varieties. And another problem looking at or working on this underutilized species is how you can conserve this species as it is already endangered. So I did tissue culture techniques for its micropropagation. At the same time, if I'm thinking if this plant could be available or could be used for example, extracting those volatiles to be used for pharmaceutical. So I need the source. So I need to propagate them, and at the same time, during the tissue culture process I use, which is somatic embryogenesis for my micropropagation, I actually also produce another variety. Yeah. So that's actually a good thing in tissue culture. You can also produce a new variety. So I'm thinking at the end of the process, aside from knowing that there are already 3 natural varieties, and then with the addition of or the use of tissue culture technique, I already added an additional variety, which can also be studied further using this flow. At the same time, I also be doing, this is next part of the study, which is a cryopreservation. So since this plant is so special, they need to be conserved because we should not take these plants from the wild. So we should be making it our research as well as the production of those pharmaceuticals to be sustainable. Yeah. So by cryopreserving this species, so we can have what do you call this we are sure that the genetic resource, the plant genetic resource is up there. It's stored, and you can have it or you can use it anytime you want. Because during cryopreservation, you can store the plant not only months, but it will be good until maybe 10 to 50 years. So this is actually what I'm doing with my research.
You have mentioned that this is an endangered plant. So the Nagoya Protocol is difficult to face. How do you manage with that? It's from Myanmar, you said?
Yes. Sorry. What do you call this? In CBD, this is actually considered as a local endangered. It's not world, so it's not under the CBD. Yeah. So it's a local endangered species.
Because sometimes it's very challenging.
Yes. So we don't need to have the permit for this.
You work with the whole plant. I mean, you're making this metabolomic in the tissue culture.
Yes. Both use the leaf and as well as the rhizome.
The rhizome has some color like
This
yellow
one,
color.
unlike maybe you're familiar with curcuma longa, so source of curcumin, it has a yellow color, but this one has white color.
I see.
White color. So it's more mainly used for volatiles. But also one good thing for this plant is also a whitening effect. So it's also good as for cosmetic.
Interesting.
Very interesting.
Variety.
Yes.
You have a new variety.
Yes. Through
Congratulations.
So I'm working with Watanabe Sensei on the patenting of those varieties.
Wow.
And is it a commercial crop in Myanmar? Do you know?
Actually, no same thing.
No,
It's
wild.
they just use it for personal use, like for cooking and tea preparation. It's not yet commercialized, so there's really a potential for this.
And then it is planted with the rhizome.
With the
It's
rhizome.
a vegetative propagation.
And with that technique I developed for micropropagation, we no longer need to use the rhizome, so I can provide already the plantlets coming from tissue.
I see. Very nice. Congratulations. Good luck. When will be the presentation, the final presentation?
Yeah, the final
Do
presentation.
you have already the schedule?
We have a pre-final presentation on October.
Okay.
Thank you very much. Yep.
Still have 15 minutes if you want to discuss the share.
You have questions?
Okay.
When you mentioned the volatile compounds, you have some specific ones that are common to this species, right?
Yeah, so it's rich in pimetoxycinamates or cinamates.
And is there any essential oil you have? I mean, you do not extract this kind.
Yeah, I did not extract the essential oil, but it has.
The chromatography.
Yes. So it's actually the whole extract which I use for the bioactivity assay.
In the work, the other studies you mentioned were from China. You said that they found out two species. And how? It's just a curiosity. You mean species? You have a genetic background that can be. You are safe. There is a new species, a new variety. Again,
Yes.
because you have some genetic difference, and also the metabolomics. You find out also the differences.
So when we apply for patent, we need those
How to
data.
prove that?
How to prove that it's a new variety. So we have the botanical, the genetic, the volatiles.
You cross all the data.
Yeah.
Okay, thank you.
We take a picture.
Fez as duas coisas.
Quem tem copo dele?
Pouquinho ali.
Você vai servir um pouquinho ali?
Very special friend. You stay some days more in Brazil? Como que nós fazemos?
Tira pra onde vocês acharem melhor aí.
Vamos chegar mais à frente aqui, então.
Vê se a luz fica ruim, como é que fica? É pra tirar um pouquinho só.
Ah, é.
Ainda com o nosso tempo.
Porque é muito tendencioso.
Sabe por quê? Na minha, from my daughter, this computer, so she loves kids.
Se deixar preto é melhor. Se deixar toda apagada a tela.
A tela apagada. Pressione OK. Não é touch. É touch?
Não sei, né?
Não dá o controle. Desliga aqui.
Foi mais fácil mesmo.
Pronto. É um colapso
Tecnológico.
É,
Será ele sair dali?
sim.
Coloca ele ali atrás. Você quer vai ter vai demorar ali?
Não, só estou ejetando.
É.
Ah, tá. Uma perninha.
Parece aquele sapato assim embaixo.
Pode tirar também só a barriga.